simple. We create a new URI based on when you, in the application itself, you can configure. This select button is actually a configure button with the first time it pops up, and then you type in an IP address, and then we create our command from the IP address, and then some string for turn on, and send a request, or we post. In this case, we're doing a post, an async post request. Very, very simple again. And like I said, you can find this code if you go to our blog. The code is also open source. There's a there's a GitHub link on there, and gives you the entire code. You can download it and run it. Again, very, very simple. And I usually walk through this in Visual Studio and show you the code there, but honestly, it's such simple code that I don't think there's a ton of value in jumping over there. But I do think that so like I said, this project here is a very simple on-off of our 110 power to control our coffee maker. But you could take this in any number of directions. Some expansion ideas that we sort of threw around to sort of add to this. You could pretty easily add a timer so that you will make sure that your coffee maker runs for no longer than an hour or something. You know, coffee does tend to get stale after a while, and probably better just to turn it off, and then you know it's time to throw it away. You could, if you're anal about your coffee temperature, you could have a temperature sensor, and you could sense the temperature of the coffee, and you could make sure that you turn off the burner at precisely the temp that you want. So you can, and then turn it back on if it gets too cold, etc. So you could do some real you do some real control feedback loops in there, and have like a real sort of smart controller as you would. Of course, you could expose push notifications, coffee maker's done, and then or even a scheduler, so that if you wake up every day at the same time, you can set your coffee maker to turn on at 6:30, and by 6:45 you get out of the bathroom or whatever, and the coffee's ready to go. And so. Lots of fun stuff that you could do here. And tonight, I actually, I mentioned I was going to show you guys something that's brand new. So this is a project we are working on that will make these kind of projects and expanding this coffee maker thing much, much simpler. And it's called Netduino.Foundation, and we haven't launched this publicly yet, so you guys are the first ones to see this. You can actually go visit this site today, tonight, whenever you want. We are going to launch it publicly Wednesday or Thursday, so don't tell too many people yet. But Netduino Foundation is, I think, truly a remarkable piece of progress for Netduino development. And let me show you guys this a little bit. It's a way to view this full size. All right, so this is the Netduino Foundation website. It's literally Netduino. It's HTTP Netduino.Foundation. I actually didn't know that .foundation or foundation was a top-level domain until I went to go buy it, and has just been launched, so that was pretty cool. It's an open source library that we have, or framework that we've created. Wilderness Labs has created, but it's a portion of it has actually been created by some of our community insiders, been writing drivers and whatnot. Netduino Foundation is at its heart a massive peripheral driver library. So one of the problems today with writing hardware applications and solutions is that if you go to SparkFun or Adafruit or whatever and you buy a bunch of sensors and some servos and other components and you want to put them together, you have to put your hardware hat on and you have to go write a bunch of low-level driver and sensor code. And with Netduino.Foundation, that's no longer the case. We've built a massive peripheral library here of common, both common core components such as LEDs and RGB LEDs and buttons and such, but we've also built up a huge library of more specialized third-party sort of non-generic components that we've got drivers for. And so it's a huge list here. So for example, the MPL, taking any one of these, MPL 3115A2 is a combined I²C temperature and pressure sensor, and you can, with Netduino Foundation, and we published these the NuGet packages last night, so you can actually, if you have a Netduino, you can go do this today. You go to NuGet and you search MPL 3115A2, and it'll pull up with a Netduino Foundation package for this. And the way that this works is that there's a Netduino Foundation core library with the generic peripheral stuff built in, and then we've published NuGet packages for all of the other external sensors and peripherals as separate NuGets, so that when you pull one in, you only need to pull what you need, sort of the .NET Core style of architecture. Because with embedded programming like this, it's important to keep your code deployment size fairly small, and so this way, we don't have massive libraries that you're pulling down. You've got a core, and then you just pick and choose what you want. And these sensor drivers are very, very easy to do, or very, very easy to use. You can see some code here. So this is a pulling. In this case, we're actually pulling, showing how to pull the sensor to get the temperature and pressure. But we also have we've built in an eventing pattern and an automatic pulling for these as well. So, say for example, with this one, instead of doing, we just haven't updated the docs here yet, but Netduino Foundation will automatically pull the sensor based on there's a default update interval, but you can pass in your own update interval. So say for example, it's ordinarily 100 milliseconds, so 10 times a second we pull these sensors. But if you're worried about battery usage and you're running something off of the solar, and maybe you only need to check the temperature once every 10 seconds, you can actually set that, and then we automatically pull. And then you can set a threshold for notification. So you can say, I only want to be notified when the temperature changes a half a degree or more. And then we handle that for you. We will pull on the interval, and then we'll only notify your application when your application wants to know if it's reached a certain threshold. And I can show you some of that code here. Here's code to do exactly that. So HIH 6130 is another one of these I²C combined temperature and pressure. HIH is actually humidity and temperature. And so this one is actually, the code here shows you setting the notification threshold to half a degree. And in this case, it's using the default polling interval, but you can change that to, like I said, you can change it to 10 seconds. In the case that you need to conserve battery, like I said, you're running this on a solar panel or something. And so this library, as I said, not only is it a massive, or this framework, not only is it a massive library of peripherals, but we also brought a much more sophisticated and modern API to these things, which makes it a lot easier to develop. And the library includes things not just drivers, not just for sensors, but there's a number of graphics display drivers, so common LCD screens, I2C, serial LCD. There's also a graphics library in there, so you can do some more sophisticated graphics stuff. There's a servo library that allows you to control servos and makes it makes servo controlling very, very easy. And as you can see, all of these things are documented, so you can find those. You can find them up here. And then, of course, as I mentioned, it's open source, so everything's up on our GitHub. It's Wilderness Labs Netduino .foundation, and it's pretty easy to find your way around in there in the source. There's the core, and then the peripheral libraries, which have all of those peripherals that I mentioned before. And then finally, there's a spot on our community site, which for Netduino Foundation. It's under here. It's here under Netduino development. You can see it. And we just created that the other day, so I don't think there's anything in it yet. But it's, I think that this is going to really change the way people do hardware development. It's really enables a much easier and much more delightful experience. I know for myself, as I started down this path, sort of building things with Netduino in a more serious way, the first thing that I was frustrated about was that, drivers were hard to come by, and I had to, I either had to go to scour the code or the internet for some old code that may or may not be still working, and it may not exist at all. And I mentioned there's one thing else I want to show you here. I mentioned that the API is pretty sophisticated. So we have been, this is, and I want to caveat here that this is still beta. We're still expanding and changing things here. But it's an elegant. There's a lot of elegance to this API. One of the things that we've done, for example, with LEDs, is that we've introduced animations. So being able to animate pulses, and we automatically walk through controlling your LED with PWM, which is pulse width modulation, and pulse width modulation is a way of controlling voltage output by cycling on and off very rapidly. So if you're outputting 5 volts at 50% duty cycle, that means 50% of the time it's on, 50% of the time it's off, and you get 2.5 volts out. So that's a way to control voltage output digitally. And so in this case, we have a pulse animation, which will automatically ramp up the duty cycle from whatever you specify. It could be like 15%. There's a lot more optional parameters to the constructor, but you can say pulse from 15% to like 90%. Will automatically create a PWM signal and cycle from 15% all the way up to 90% and back, and it creates this like really nice animation effect. And if you're using an RGB LED, then you can, let me find that. If you're using an RGB LED, then you could walk through the hue spectrum by simply looping through 360 degrees of hues, and then setting your color on your RGB to that hue, saturation, brightness color. And we've got a nice structure that for dealing with colors and whatnot, and you can even pulse different colors. You can say pulse color.aqua, or you pass in a hex string, etc. So we've been spending a lot of time on these APIs to really craft something that's really nice and elegant to use, which is a really if you've done embedded programming, you'll know that a lot of the stuff out there, the tooling and the APIs are not like this. So definitely check it out. And I'm pretty proud of what we've done so far. And like I said, it's still beta. This is pre-release. The site actually isn't even done yet. We're writing API docs, but that section is still a little bit shy on content. Although we have documented all of the peripherals, we haven't updated their API docs to use the new eventing and notification API that we've been adding though. So anyhow, like I said, check it out. I think that you'll dig it, and I think it'll make Netduino development a lot easier. And that's it for tonight. So it's a real short, deck, partially because there's going to be a gazillion questions. We'll definitely, there always is. So it's like a half-hour deck and an hour of questions. But you can find these slides up here at slideshare.net/Bryan Costanich. And once you find the slides, then you can click on all the links. The code is here at our GitHub, github.com Wilderness Labs. You can find stuff there. And then also our blog has how to build this copy maker. This is very easy to do. And if you have a 3D printer, you can print this board, or if you don't, you can, and you've got a saw and a drill, you can make it out of plywood. All the dimensions are up in our 3D print repo. So I encourage you to go start playing around with this stuff. Get a Netduino off of Amazon, and we're actually going to give one away tonight. So someone here lucky will get that. So yeah, buy a Netduino. Help us build our next thing, and go try Netduino Foundation, and give us feedback, and give me feedback. I brought some stickers, so if you guys want to take one and pass them around. Here you go. All right, so question and answer, and I know there's should be a million of them. So first, over here.
Yeah, so back to the topic of building a connector appliance with Netduino and Xamarin.
Yeah.
So we saw some sample code for sending a value to a port,
yes,
toggle relay. But for those of us who are new to building an application with Xamarin and Netduino, I'm guessing there are two things we have to build: a Xamarin application that runs on a device,
yeah,
and a web service component that runs on the Netduino. And I'm thinking that that's what that sample code was for. But how would we go about actually building a Xamarin app, and what would we do with that code to get it onto a Netduino running under a web server?
Yeah.
How would we actually build this application?
It's a good question, and I can show you actually if studio. So the building a .NET micro framework app. So there's two pieces to it. There's two pieces of the thing that I showed you tonight. There, as you said, there's the Xamarin app, and there's the .NET micro framework app. Now, the Xamarin app can be anything. In fact, to test this out, we were using Postman, which is just an application to perform GET, to do HTTP requests, to test RESTful APIs. So we're exposing the API to control this in a client agnostic way. You could have opened up a browser and controlled this the application, or you could use Postman. In fact, I think I might have Postman. Yeah. So here's Postman, This is actually showing, so this is sending a request to, I don't know how to.
Well, sure, I know how to construct an HTTP request using
Yeah.
a developer tool, but I thought this talk was about using Xamarin to build an app.
So Xamarin is part of it, certainly. But the real, the real, I think the real value here is not the Xamarin app, but the .NET Micro Framework app, because that's the app that actually lets you control the appliance. It could be, you could control that via Xamarin app, you can control it via a website. You know, you could expose a website someplace that talk to the server. You can control it any number of ways. You could write a Windows application. That's really not, in my mind, that's less important because you have a choice there. You could control it any way you want. Now, the .NET Micro Framework side of the equation is something that that's a little bit different. So to create a .NET Micro Framework application, you install the .NET Micro Framework SDK, and there's a link up on our website on how to set up your development environment. So if you go to developer.wildernesslabs.co, there's a getting started link, and that walks you through installation and setup of your development environment. And it works in both Visual Studio for Windows and Visual Studio for Mac. I will warn you that right now our Visual Studio for Mac debugger is broken. Rosalind broke us, and we're fixing that. So we're very young. We're still very early in our progress here, but we'll get that fixed. So right now, the development experience is definitely